Chain drive is a way of transmitting mechanical power from one place to another. It is often used to convey power to the wheels of a vehicle, particularly bicycles and motorcycles. It is also used in a wide variety of machines besides vehicles. Most often, the power is conveyed by a roller chain, known as the drive chain, a transmission chain, passing over a sprocket gear, with the teeth of the gear meshing with the holes in the links of the chain. The gear is turned, and this pulls the chain, putting mechanical force into the system. Another type of drive chain is the Morse chain, invented by the Morse Chain Company of Ithaca, New York, United States. This has inverted teeth. Sometimes the power is output by simply rotating the chain, which can be used to lift or drag objects. In other situations, a second gear is placed and the power is recovered by attaching shafts or hubs to this gear. The drive chains are often simple oval loops. They can also go around corners by placing more than 2 gears along the chain. Gears that do not put power into the system or transmit it out are generally known as idler wheels. By varying the diameter of the input and output gears with respect to each other, the gear ratio can be altered. For example, when the bicycle pedals gear rotate once, it causes the gear that drives the wheels to rotate more than one revolution. History. The oldest known application of a chain drive appears in the polybow as a repeating crossbow described by the Greek engineer Philon of Byzantium. 2 flat-linked chains were connected to a windlass, which by winding back and forth would automatically fire the machine's arrows until its magazine was empty. Although the device did not transmit power continuously, since the chains did not transmit power from shaft to shaft, and hence they were not in the direct line of ancestry of the chain drive proper. The Greek design marks the beginning of the history of the chain drive, since no earlier instance of such a cam is known, and none as complex is known until the 16th century. Quote, "It is here that the flat-link chain, often attributed to Leonardo da Vinci, actually made its first appearance. The first continuous and endless power-transmitting chain was depicted in the written horological treatise of the Song dynasty Chinese engineer Su Song, who used it to operate the armillary sphere of his astronomical clock tower, as well as the clock jack figurines presenting the time of day by mechanically banging gongs and drums. The chain drive itself was given power via the hydraulic works of Su's water clock tank and water wheel, the latter which acted as a large gear. Chains versus belts. Roller chain and sprockets is a very efficient method of power transmission compared to belts, with far less frictional loss. Although chains can be made stronger than belts, the greater mass increases drivetrain inertia. Drive chains are most often made of metal, while belts are often rubber, plastic, urethane, or other substances. Drive belts can slip unless they have teeth, which means that the output side may not rotate at a precise speed, and some work gets lost to the friction of the belt as it bends around the pulleys, whereon rubber plastic belts and the teeth is often easier to observe, and chains wear out faster than belts if not properly lubricated. One problem with roller chains is the variation in speed, or surging, caused by the acceleration and deceleration of the chain as it goes around the sprocket link by link. It starts as soon as the pitch line of the chain contacts the first tooth of the sprocket. This contact occurs at a point below the pitch circle of the sprocket. As the sprocket rotates, the chain is raised up to the pitch circle and is then dropped down again as sprocket rotation continues. Because of the fixed pitch length, the pitch line of the link cuts across the chord between 2 pitch points on the sprocket, remaining in this position relative to the sprocket until the link exits the sprocket. This rising and falling of the pitch line is what causes caudal effect to speed variation. In other words, conventional roller chain drives suffer the potential for vibration, as the effective radius of action in a chain and sprocket combination constantly changes during revolution. If the chain moves at constant speed, then the shafts must accelerate and decelerate constantly. If one sprocket rotates at a constant speed, then the chain must accelerate and decelerate constantly. This is usually not an issue with many drive systems. However, most motorcycles are fitted with a rubber-bushed rear wheel hub to virtually eliminate this vibration issue. Toothed belt drives are designed to avoid this issue by operating at a constant pitch radius. Chains are often narrower than belts, and this can make it easier to shift them to larger or smaller gears in order to vary the gear ratio. Multi-speed bicycles with derailleurs make use of this. Also, the more positive meshing of a chain can make it easier to build gears that can increase or shrink in diameter, again altering the gear ratio. However, some newer synchronous belts have equivalent capacity to roller chain drives in the same width. In other words, a toothed belt as wide as a chain drive can transmit the same, or even slightly higher, amount of power. Both can be used to move objects by attaching pockets, buckets, or frames to them. Chains are often used to move things vertically by holding them in frames, as in industrial toasters, while belts are good at moving things horizontally in the form of conveyor belts. It is not unusual for the systems to be used in combination. For example, the rollers that drive conveyor belts are themselves often driven by drive chains. Drive shafts are another common method used to move mechanical power around that is sometimes evaluated in comparison to chain drive. In particular, belt drive versus chain drive versus shaft drive is a key design decision for most motorcycles. Drive shafts tend to be tougher and more reliable than chain drive, but the bevel gears have far more friction than a chain. For this reason, virtually all high-performance motorcycles use chain drive, with shaft-driven arrangements generally used for non-sporting machines. Toothed belt drives are used for some models. Use in vehicles. Bicycles. Chain drive was the main feature which differentiated the safety bicycle introduced in 1885, with its two equal-sized wheels. For the direct drive penny farthing or high-wheeler type of bicycle, the popularity of the chain-driven safety bicycle brought about the demise of the penny farthing, and is still a basic feature of bicycle design today. Automobiles transmitting power to the wheels. Chain drive was a popular power transmission system from the earliest days of the automobile. It gained prominence as an alternative to the system Panhard with its rigid Hotchkiss drive shaft and universal joints. A chain drive system uses one or more roller chains to transmit power from a differential to the rear axle. This system allowed for a great deal of vertical axle movement, and was simpler to design and build than a rigid drive shaft in a workable suspension. Also, it had less unsprung weight at the rear wheels than the Hotchkiss drive, which would have had the weight of the drive shaft and differential to carry as well. This meant that the vehicle would have a smoother ride. The lighter unsprung mass would allow the suspension to react to bumps more effectively. Fraser-Nash were strong proponents of this system, using one chain per gear selected by dog clutch. The Fraser-Nash chain drive system was very effective, allowing extremely fast gear selections. The Fraser-Nash transmission system provided the basis for many special racing cars of the 1920s and 1930s, the most famous being Basil Davenport's Spider, which held the outright record at the Shelsley-Walsh Speed Hill Climb in the 1920s. The last popular chain-drive automobile was the Honda S600 of the 1960s. In motors, internal combustion engines often use a timing chain to drive the camshaft. This is an area in which chain drives frequently compete directly with belt drive systems, particularly when the engine has overhead camshafts, and provides an excellent example of some of the differences and similarities between the two approaches. For this application, chains last longer, but are often harder to replace. Being heavier, the chain robs more power, but is also less likely to fail. The camshaft of a four-stroke engine rotates at half crankshaft speed, so the camshaft gear has twice as many teeth as the crankshaft gear. Less common alternatives to chain drives include trains of spur gears or bevel gear and shaft drives. Transfer cases today, inverted tooth drive chains are commonly used in passenger car and light truck transfer cases. Motorcycles. Chain drive versus belt drive. The use of a drive shaft is a fundamental design decision in motorcycle design. Nearly all motorcycles use one of these three designs. See Motorcycle Construction section Final Drive for more details. Bibliography. Green, Robert E. al. Machinery's Handbook, New York, USA. Industrial Press. ISBN 978-08311-25752. Sclater, Neil. Chain and Belt Devices and Mechanisms. Mechanisms and Mechanical Devices Source Book. 5th ed., New York, McGraw-Hill, pp. 262-277. ISBN 9780071700427. Drawings and designs of various drives.